This video corresponds with Lesson 1 in Unit 4C, which will talk about how to graph quadratic functions in standard form. This is the first of 3 ways that you're going to learn how to graph quadratic functions, aka functions that deal with expressions that have an x squared in it. So, we're going to look at a couple of examples here. These correlate directly to your notes. They're formatted a little bit differently, but you'll still get the same general ideas to the different things that you're going to need to look for. So, we look at this first example here. Y equals 2x squared minus 8x plus 6. When we graph a quadratic function, it's a little bit more complex than just graphing a regular line. What quadratic function graphs in the shape of what's called a parabola, it's basically a U-shaped graph that's either going to point upward or downward. So we're going to need to look for a couple more points than we would if we were just graphing a regular line in, say, slope-intercept form. There's a little bit more to this. So let's look at all the different components that we need to find and then figure out how to graph it. So the first thing we're going to do, you'll notice I have 6 little bullet points here. First thing we're going to look for is we're going to identify the A value. The A value is going to give us a clue as to which way this graph will open. So if you understood how to get the A value when we did all the other solving stuff in the last couple of chapters, the A value is simply connected to the x squared term. So in this case, the A value is 2. Anytime the A value is a positive value, we're going to know that the parabola will open upward. So you'll see once we start plotting some points here that everything will be pointing upward in our graph. The second thing we have to find in the parabola is the vertex. The vertex is basically the starting point of our graph. If you recall back earlier in the year when we did absolute value graphing, so the graphs that looked like these, once we found the vertex, it was a lot easier to go find all the other points after it because you knew where to start. For quadratic functions, for parabolas, it's the same thing. So I'm going to go ahead here and find the vertex. But in order to do so, we have to use a little bit of a formula to figure out how to get started. So to find our vertex point, we need the x-coordinate of it first. To find the x-coordinate, we're going to use this little formula, negative b over 2a. So I'm going to go back to my original problem. I'm going to plug in negative 8 for b and 2 for a. So I'm just pulling those as coefficients right out of the problem. And I'm going to go ahead and simplify. So I'll get 8 over 4, which is 2. So the x-coordinate of vertex is going to be 2. To find the y-coordinate, a little less complex. If you know x, go plug it back into the original problem and get y. So all I'm going to do here is plug in 2 where we see x. So I'm only going to show this here one time here so you can see visually what I am talking about. So all I'm doing is simply this. So anywhere I see a 2, I plug it in. Now, you don't need to write out this work. In fact, I think it'd be a little more cumbersome to do so. Use your calculators. Your graphing calculators will handle all this math in one shot. The biggest thing I cannot stress enough is when you substitute in, be sure to put things in parentheses, especially if you're substituting in negative numbers. We do that, the y value is going to be negative 2. So your vertex is going to come out to 2 comma negative 2. Once you have your vertex, you can go ahead and plot that point. And that's where your graph is going to start from. Now, before we just go ahead and blindly get more points, what we're going to do here is draw in something called the axis of symmetry. Parabolas are symmetrical graphs, meaning that if you know one side of the points, you can reflect it over this imaginary line called the axis of symmetry and get the other side of points without having to do any computation. So we're going to draw in the axis of symmetry. All the axis of symmetry is, it's a vertical line, and we're going to put it in as dotted because it's technically not part of our graph, but we do it as a visual aid. It always goes through the vertex every single time. So I'm going to go ahead and draw in that axis of symmetry right after I plot the vertex. I'm going to write the equation for it. For every vertical line, it's always an x equals line. Well, what does x equal? It ran through 2. It's always x equals the x-coordinate of the vertex, and that's our equation for the axis of symmetry. Once we have those things, we are going to go ahead and find a couple more sets of points so we can actually make our graph. Now, you'll see in some of the notes, sometimes I ask you to find the y-intercept. The reason why I do that is because if you remember how y-intercept works, the x part of the y-intercept always has to be 0. So this will allow you to do pretty quick math without having to do a ton of plug and chugging all the time. Sometimes the y-intercept fits on your graph, sometimes it doesn't. If it does, great. If it doesn't, you're basically going to pick points that have to be close to your line of symmetry. The further you are from the line of symmetry, the more likely you're going to pick a point that will exist, but it won't fit on your graph. In this case, 0 is pretty close to the line of symmetry, so there's a good chance it's going to fit. So to find my y-intercept, I plug in 0 for x. Again, use your calculator for the computation here, or just look at it and realize, hey, if I plug in 0, y is going to be 6. So my y-intercept is 0, 6. I'm going to go ahead and plot that. Now, you'll notice next to it I have something called a symmetry point. All this means is if I look at 0, 6 and where I've plotted that, we are 2 spaces to the left of the line of symmetry. That means if I go 2 spaces to the right and reflect it perfectly, all we have is a point that's going to be on the graph. You can check this. It'd be 4, 6. You can plug that into your original equation, and it's going to work out. That's the great thing about having that line of symmetry. If you know the points on one side, all you got to do is count the same number of spaces the opposite direction, and you'll get another set of points. So that way you can make both sides of the graph. So once you find that, again, we need to find 2 pairs of points. Having these 2 pairs of points plus the vertex, that gives you 5 total. That's enough to make an accurate parabola, and that's what my expectation will be no matter what form we graph these in. So it says to pick another point. I'm going to pick an x value, again, that's close to my axis of symmetry that I haven't used. I haven't used 1, so I'm going to go ahead and plug that in. And once again, plug 1 in for x in the original problem. It's going to spit out 0, so I have the order pair 1, 0. I'm 1 space away, so the symmetrical point, if I go 1 space the opposite direction, will be 3, 0. So I have my 5 points, and I can go ahead and trace them. When you do this, you're going to go ahead and try to make a U shape, okay? These don't make V's, they make U's, okay? Because these are not perfect straight lines on both sides. They're going to curve a little bit. So do the best that you can. I mean, you can see mine here. It's not perfectly accurate, but you get the general gist of the shape. You've got your 5 points, you've got your graph, and that graphs the function there. So the last tiny bit of this is to analyze whether it has a maximum or a minimum. All this means is this. If the graph has a maximum, it means the graph has a peak to it. So if you look at it visually, if it looks like it's a mountain, if you will, it has a peak, it has a max. If it has a minimum, that means it's going to have a valley to it. It has a bottom point in which everything goes up from it. This graph specifically has a minimum because it has a low point. So, and again, to emphasize that here, here's my low point. Now, the maximum or minimum is going to be located at your vertex. So these couple little blanks that are next to it are just basically saying, hey, where's the minimum occurring and at what x value? Well, the minimum, the low value in terms of the y, it's the lowest point is that y is equal to -2. And at what x value? X being +2. Those two numbers come right for the vertex. And that'll be the case every single time I ask you, where is the maximum or minimum located? It's always at the vertex. It's just a different way to phrase it and split that information apart. So that, in short, is how you graph a quadratic function in standard form. We're going to go ahead and take a look here at a second example in which we're going to see the exact same thing, but figure will show you a graph going the opposite direction. So here I give you the function y equals -1/2 x squared plus 4x minus 6. I'm going to do the same thing with this. I'm going to identify the a value, which is -1/2. If the a value is negative, that means it's going to open downward. So the last graph, we had a positive a value, it opened up. If this has a negative a value, that means it's going to open down. Again, visual clues to help you keep things in mind. Now we're going to go ahead, find the vertex, which will help us put everything else into play. So once again, to find the vertex when it's written in standard form like this, we start off with x equals -b/2a. We'll plug in 4 for b, -1/2 for a. So we'll end up having -4/-1, which means the x value of the vertex is a +4. Once again, to find the y value, take the x, go plug it back into the equation. You do some quick calculations on your calculator. You get y equals 2. So your vertex is at 4, 2, and there is your starting point. Once you have that, you can go ahead and draw in that axis of symmetry, because at the vertex, that's where this graph would fold in half, nice and perfectly. So we're going to go ahead and draw on that line. Once again, axis of symmetry is an x equals equation, because that's how we write the equation of a vertical line. And it runs through the point of the x-coordinate of 4, which again directly correlates to the x-coordinate of your vertex. Now that that's done, we're going to go ahead, find two pairs of points. So once again, I have listed, let's find the y-intercept. Again, reason being, that means x has to be 0, so that makes for some quick math. So if I plug 0 in for x, it spits out -6. That fits on our graph. Perfect. We're going to go ahead and plot it. So as long as it fits, you're in good shape. We're going to reflect it. So it was 4 spaces to the left of the line. Now we're going to go 4 spaces to the right of it. The symmetrical point today would be 8, -6. And now we're going to go ahead and pick another point. So again, looking at this problem, knowing that I'm going to have to multiply by -1/2, I'm going to go ahead and choose 2 as an x value because it's even. You could pick 1, you could pick 3, 5, whatever. You can pick any number you want. Sometimes you might get decimal points, which again is not a bad thing, but just something you have to be careful with in terms of how you graph it and how you compute it. So I'm going to go ahead and pick 2. And once again, if I plug 2 in for this, 2 goes in for x and ends up spitting 0 out for y. So it gives me a nice point of 2, 0. I can reflect it. It was 2 spaces to the left. If I reflect that point, 2 spaces over the other way, symmetry point of 6, 0. So again, the nice thing about these graphs is that they are symmetrical. So if you're getting graphs that are weirdly spaced apart, that's going to give you a visual clue. Hey, you might have plotted something wrong, or your math might be a little bit off. So I have my 2 pairs of points. I have my vertex. I can now go ahead and make my parabola. It's pointing downward. We talked about that a value at the beginning. It was a negative a value. That means it should be downward. We're in great shape. So again, the last little bit here is doesn't have a maximum or a minimum. You can see this graph has a peak to it. It tops out. Okay, it has a high point. So we say it has a maximum. The maximum is located at the y value of 2. And that y value of 2 is located with an x value of 4, which again connects back to our vertex. So like I said, this is one of the ways that you're going to know and learn how to graph these types of problems here. Again, this is called graphing in standard form. You're going to learn other ways to graph, one being vertex form, where the way the equation's written, vertex can be really easy to pull out. It's a little less complicated than what you saw here. And you'll also learn how to graph in something called intercept form, where you're going to be given the x-intercepts to easily find and pull your points from there. So different ways to graph. This is the first of the 3. And that explains fully how you graph in standard form.